Hello everyone. Today let us discuss about some of the topic from the supervised machine learning, that is support vector machine. Support vector machine is a supervised machine learning which is used to solve the classification and regression problem. However, the primary use of the classification problem in the machine learning where it is supported by the support vector machine algorithm. It is this algorithm is used to create the best line or the boundary that can segregate the n-dimensional space into the classes so that can we easily put the new data in the current category in the future. This best decision boundary is called as an hyperplane. The meaning of this decision boundary is nothing but, so you can look into this two diagram. Here the two classifiers are there, means two different types of the points are there. One is in the blue color, one is in the green color. So if any line, if we write as a boundary to differentiate these two classifiers, that is called as an hyperplane. So in the second diagram you can look, we have written the two lines here, means two hyperplane here which separates the two classifiers. So among this we have to choose the best line which can become the hyperplane of this SVM. How to choose the best line means, so let us consider the one more example where the green color and the blue color classifiers are there, and we have written the three lines which are differentiating these two boundaries, means these two classifiers with the boundaries. So among these three we have to choose the one of the best line as a hyperplane of this SVM. So how to choose this best hyperplane means, we need to draw the parallel line to the each and every straight lines where those parallel lines should meet the nearest data points in each classifiers. So after writing those margins or the parallel lines, we need to calculate the maximum value of that margins. So which is having the maximum margin value, that will become the hyperplane. So among these three, see if I write the margins, that is a parallel line for the both the classification, any one hyperplane will be having the maximum margin. That hyperplane is considered as in hyperplane of the given SVM, and that data points which are lie on that margin values are considered as in support vector. Here for this one, if this is considered as an hyperplane, then this point and this point are considered as a support vector of this hyperplane. Because of these points only, this hyperplane is identified and chosen. That's why these are considered as a support vector for this given data point. So while writing the margins, so this is what happens. So any line which belongs to one classification, so the hyperplane equation is given in such a way that w into x plus b. So w into x plus b, if the value is greater than 1, then that belongs to the class 1, which are the positive classes, and this equation is less than minus 1, these are belongs to the classifiers of the negative classifiers. So this entire line is considered as an hyperplane, and these are the data point which are in bold color, indicates that these are the support vector of this given data point. So the dimension of hyperplane depends upon the feature present in the data set, where if two features are there, then the hyperplane will be the straight line. If the dataset is having the three feature, then the hyperplane will be the two-dimensional plane. We also create the hyperplane that has a maximum margin, which means that maximum distance between the data point. The data point or the vectors that are closer to the hyperplane, which affect the position of the hyperplane, are considered as a support vector. As I told in the previous diagram, the support vectors are the lines which are noted or identified in the margins. Since these vectors are support the hyperplane, hence they are called as a support vector. So this is what the hyperplane, and these two are the margins whatever we have written. So one is belongs to negative classification, one is for the positive classification. How the maximum value is calculated is the 2 by weight value. So that the weight into x plus b is the hyperplane equation. By visually we can draw the hyperplane parallel lines to the given hyperplane, and we can choose which can be the hyperplane for the given support vector machine. So same way the calculation of the maximum margin can be done in the mathematical way, that is with the using the hyperplane function value. Hyperplane function is given in the form of b plus a1 x1 plus a2 x2, where the b is the intercept and a1 is the coefficient of x1 and a2 is the coefficient of x2. So if it is in visually, we can draw the parallel lines to the given hyperplane and we can calculate the maximum margin. So if it is in the mathematical form, so one equation is given for the one classifier, that is a 5 plus 2x1 plus 5x2, which is in the form of this function. Same way, one more equation is given for the classifier 2, that is 5 plus 20x1 plus 50x2. Now let us calculate the distance error function formula for this one to to pick the good classifier to construct the hyperplanes, to identify the hyperplane. So the distance error function is given by, for the SVM is given by square root of a1 square plus a2 square. From the equation of the classifier 1 and classifier 2, if we apply this formula, we are getting the distance error for the first hyperplane is the 5.39 and the second hyperplane value for the 53.85. Among these two, again we need to calculate that maximum margin, that is the 2 divided by 8 of that value. So 2 into this distance error value, I am getting the 0.37. Same for the classifier 2, I am getting 0.037. So among these two, classifier 1 is having the maximum value, so we will choose the first hyperplane equation as the best SVM. So in this way we can choose the hyperplane for the both the positive and the negative classifier. Means if you have written the more number of hyperplane, if you have the more number of straight lines, that is the boundary to differentiate, so among those we can choose the any one. So next let us discuss about the types of the SVM. So one is the linear SVM and another one is the non-linear. So linear SVM is mainly means it is used for anywhere straight line is enough to differentiate the two classifiers for the given classifier, then we will call it as a linear. If the line, if the data points are not linearly separated, and if means the data set cannot be classified using the single straight line, if we require the more than one straight line likewise, we will call it as a non-linear.